we are going to apply dynamic programming. So what are the things are required to apply dynamic programming? Already I told you. One is, first step, we are seeing optimal substructure. So I will explain you that there is an optimal substructure. Okay, it comes by practice. If you see optimal substructure here, and in the next problem if you see again optimal substructure, then what happens? Eventually you will understand what is optimal substructure. Then in the new problem you can see the optimal substructure. That's why learn optimal substructure through various examples. So here in this problem I show you. Second, after that, once you have optimal substructure, then we are going to develop a recurrence relation for the problem. We'll see that. After that, we are going to implement that recurrence relation. These are the very important properties of any dynamic programming. So what are the things I'm going to do is, first I will show you optimal substructure. After that I write recurrence relation for that. Then for the problem, after that I implement in a bottom to top approach, remember. So then only you get best time complexity. Otherwise, you know what happens, if you implement recurrence relation of your dynamic programming directly from top to bottom, then time complexity will not be reduced. It will be again 2 to the power of n. So what was the time complexity of brute force method? 2 power n, right? So same thing happens for this one also. That's why these are the 3 steps always we are going to do. See the optimal substructure. If it is there, then apply the recurrence relation to solve the problem. So this is very tricky part. How to write recurrence relation for solving the problem is a tricky part. This will comes by practice. Now after that, implementation. So how to implement is bottom to top approach. I will explain that. So these 3 things you learn with the examples. Let's begin with this problem. In this problem, first of all, before showing optimal substructure, I introduce a variable called f. So f1 comma I. So what is the meaning of f1 comma I am writing? f1 is nothing but it is the path. What kind of path is shortest path? Here, with respect to cost, here generally, and one more point I would like to mention, whenever you are applying dynamic programming, that kind of problems are also known as optimization problems. So here generally whenever we apply dynamic programming, we either optimize something, otherwise we maximize something or minimize something, that is definitely. So most of the times, so dynamic programming generally whenever you want to apply, check is it optimization problem. So it is optimization problem here. Why? So if you see how it is optimization problem is, we are optimizing what are you doing here? We want to find out a path which has cheapest cost, correct? Every path is associated with one cost, correct? Cost, what is that cost? That assembly creation time of the vehicle or something for previous example. Otherwise this is one assembly unit. So here you are manufacturing something, then manufacturing cost, correct? So now what I want to say is, so in this problem we are going to find out cheapest or costly one, costliest, no, cheapest, right? I want cheapest or shortest one. So here our problem is especially finding the cheapest path. Sometimes what happens, there are some problems where you might require longest, maybe longest something, otherwise shortest. So these are the keywords will help you in deciding whether it is dynamic programming problem or not. So these are all, whenever you are finding something cheapest or longest or shortest, otherwise highest or everything, so either maximum or minimum. So these are all maximum or minimum, correct? So whenever you are finding something maximum or minimum, that kind of problem generally comes under dynamic programming. So here especially this problem is finding the cheapest cost possibility, correct, for assembling the product or something. Then for that, what we are going to do is we are introducing a variable f1 comma I. What is f1 comma I will tell you. So every path has a cost, right? Then f1 comma I is nothing but, and every path is going through some stage, correct? Example, here if you take this path, then that path is coming through A22, coming through A23, so on, right? So example, what is f1I is, it is best path. What is best here for us? Cheapest path. Okay, so it is cheapest path with respect to cost, otherwise cheapest cost path or minimum cost path, anything is correct, right? So minimum cost path which is going through stage I, just it is going through stage I. So that is what the concept of f1 comma I. So let's try to understand this with example. What is F11 we will see. F11 is, according to our definition, in the line, this one indicates line number 1. So this is stage number 1. In the stage number 1 and line number 1, that means I want to know the shortest path possible which is going through just stage number 1. If you see, if any path is just going through stage number 1 from line number 1, what is the cost of that? There is only one cost. What is that? E1 plus A11. So that is the meaning of F11, E1 plus A11. Sir, what is F12 then? Cheapest path which is going through stage 1, 2. This is stage 1, 2. So imagine like this. Some path is going through like this. For that there are two possibilities. It can come like this or like this. Then what is cheapest or minimum cost path we have to find out. That is what F12. Example, one path is E1 plus A11 plus A12. Second one E2 plus A21 plus shifting cost. What is shifting cost? Already I told you T21, correct? T21 plus A12. So here I would like to find out shortest minimum cost path, right? So that is F12. So take these two possibilities and find out the minimum, right? In that way every node has this value. Example, here we have F13, here we have F14, here we have F24, so on, right? Now you tell me what is F1i finally. F1i is minimum cost path which is going through line number 1 and stage number I. Understand? Similarly we can define F2i. That is also same. Minimum cost path which is going through stage I on line number 2. Now we are going to derive recurrence relation for this one. I will tell you why. So what is our problem is, I will tell you. Before that there is an optimal substructure. What is optimal substructure? I will tell you. To problem, what is our problem here? Finding the minimum cost path which is going through where? Anywhere. Either it can go through here or it can go through here. You tell me one possibility. Is there any path which is your answer which is not going through this stage? Yes. Then it should go here. If it is not going through this one, it should go here. Is there any path which is neither going through A14 or A24? Impossible, right? Definitely either this stage or this stage should be to be taken into consideration, correct? So finally what I want to say is your shortest path or cheapest path definitely should go through this stage. Let's say, but example, there are two paths. One path is taking 70 rupees cost. Okay, there are a lot of paths which are going through this one. 70 rupees path, 80 rupees path. Then what is cheapest here? Let's say there is 60 rupees path. Definitely 60 rupees path is cheapest, correct? According to our definition, that is what F14, correct? What is the cheapest path which is going through stage line number 1, stage number 4 here? 60. So 60 is that one. So I am slowly relating my variable F1 comma I to these values. Understand? Now example, let's say any path among all the paths, what is the cheapest path which is going through A14? Let's say 60 rupees path. Let's say what is the cheapest path which is coming through A24 is 30 rupees. Okay. Then this x1 value which is exit cost something 70 rupees and this exit cost is 100 rupees. You tell me now which one is best. Otherwise let's take 90. So there are only two best paths possible. One best path goes through A14. Second best path comes from A24. The best path which is coming from A24 is 30 rupees. Here it is 60 rupees. Then the overall best will be 60 plus 70 or 30 plus 90. Correct? Min of 60 plus 70 and the second one 30 plus 90. So there cannot be any other path possible which is best. Correct? Sir, I have seen one best path which is neither 130 nor 120. But I have seen it. Then I ask you one question. That path definitely should come from here, right? No, sir, it is not coming through this one. Then it is coming from where? Sir, it is coming from this, sir. So definitely either we know that either it should come from here or it should come from here. If it is coming from this stage, it is going through this stage, then among them who is the best one? 60 rupees I considered. Then you will be, if you want to cheat me, then you should say that, sir, no sir, there is a 50 rupees path. Then 60 cannot be minimum, correct? So finally what I want to say here is, to say that something is best path, first of all it should definitely, we should know that we know that it is going through A14 or it is going through A24, that is for sure. Among them, when let's say there are lot of paths which are going through A14, which one we have to choose for overall best? Definitely we have to take the best path which is going through A14. Now here I show the optimal substructure. What is the optimal substructure here is this is your problem with multiple stages. Okay, then you are here. Now to finally to reach here in a best way. Okay, this is final destination. For that either I have to take this path or interleaving, but finally eventually you have to visit some, let's say, stage number K, correct? Yes. So we have to visit either this stage or this stage, but my question is, example, really you are visiting this stage, that is for sure. God said that. God said really you want to have a best path overall, you have to visit this stage, let's say. Then that stage number is 1 comma K. Now you tell me how to come to that K, stage K. How to come through the stage K? I mean, to come to the stage we have to start at initial stage, right? From initial stage, how you come to this path, this stage? There are lot of things, correct? Which one you choose? Definitely to have overall best, definitely we have to visit that path, whatever you are saying, best path. Okay, let's say there is a best path for your problem. That best path is best only if that goes through this stage, then that going through that stage also should be done in best way. No sir, what I do is, there is a stage called second stage, let's say. Okay, this is my overall problem. What I do is, God said I have to visit second stage, this second stage, not this second stage. Then only it is going to be best path. Okay, fine, then I agreed. Then I am going like this. Then I just visited second stage and I am going out from that because I want to form the best path. Then, but what I did is, I have taken a path which is going through second stage, but not in a best way. It is an ordinary way. It is worth 70 rupees. There is a best way, same thing. That means I can visit the second stage with 50 rupees. I can go through that second stage with 50 rupees, but still I choose 70 rupees. Then I ask you why? Then only I am getting best path. It is wrong, because if you take 70 rupees path, still you get best path. Then rather than taking 70, replace that with 50, take the another path, correct? Up to this one, you are saying that, sir, up to here there are two stages in my journey. One is, this is second stage, let's say. Then up to this second stage I spent 70 rupees, but here I spent like anything very cheapest path I have taken, that is just 30 rupees, sir. Then overall how much it will become? 70 plus 30, and you are claiming that is best. Then what I do is, your path from here to here, whatever you have, that I remove, and I know that there is a best path of 50 rupees, I replace here, still it will form a path, correct? That will cost only 80 rupees. That's why now I realize that at any stage, example, you want to go through all the stages in a best way, then example, for that if you have to come to here, I'm not saying that you have to come here. If you come here in the path while going through the best path, if you come here, but that coming also you should do in a best way. Yes, that's why it has optimal substructure, right? What is my sub problem? To solve, to come to this, then we have to visit this stage or this stage, but visiting that stage should be done in dash way, ordinary way? No, definitely best way. Yes or no? Do you agree? Yes, that's why this problem has optimal substructure, correct? So whenever this problem has optimal substructure, then we are going to write recursion relation. That is what the style of dynamic programming. First identify optimal substructure. Let me clearly explain you optimal substructure or summarize it. Simple. If you want to find out, otherwise if you want to come, finally we need paths, right? I want best path. You know what is best path? If you want best path overall, then that best path, if it visits this stage, then before that, see, it is visiting this stage means what? Before that, that path is coming from the start, right? From start to this also, that path should come in a best way. Example, your final answer is, this is best path. Okay, then it is starting at some, starting anywhere, something starting point. This is starting point, this is ending point. This is, let's say, your claim that best path. What is best path here? Which has minimum cost. Then I'll ask, example, I identify that this is some stage X. Then I'll ask this question. From here to here in this path, did you come in a best way? Yes. From here to here, did you come in a best way? Yes. So to have overall best path, here to here also should be, it should be best path. That means minimum cost path. And from stage X to final stage also, the path should be best cost path. Then only overall will become best cost path. Agree or not? Yes. If you don't agree, then always I can say, let's say you don't agree, then this is not best. This is second best and 30 rupees. And best, let's say you have taken here best, then 70 rupees, 30 plus 70, 100. Then I always replace your second best with first best, then I'll get better path. Then this is not best path if there is a better path than best, correct? So always I can say that whenever you want to have a best path from here to here, there are a lot of paths. We know there are 2 to the power of n paths. Out of them, your answer, let's say, what we don't know what is that, but it is, let's say, best path. So finally you got a best path, then that best path has this property. What is that? So in that best path, if you identify any intermediate stage, correct? Because that best path should go through all the stages. Then example, this is the intermediate stage. Then to visit that, definitely that path is going through the stage, right? Then that going through that stage should be done in what way? Best way. That means with minimum cost way. And from this stage, and we have to finish the total path in a best path. Then only overall will become best. But this is not always the case. Don't think that every problem will have this kind of optimal substructure. No, there are some problems I will show you which doesn't have optimal substructure. Example, longest path. Example, let's say you want to find out longest path from Hyderabad to Kolkata. Longest path. In between there are 2 intermediate stages. I'll take simple problem like this. So Hyderabad to Kolkata, in between we have, let's say, so Vizag something, and second one, let's say you have Patna. My question is, I want to go from Hyderabad to Kolkata in longest way. We have a loop here, let's say. So cost from Hyderabad to Vizag is 5 rupees. Here let's say 10 rupees. Here let's say 10 rupees. Here let's say 5 rupees. Then you tell me, what is the longest path from Hyderabad to Kolkata? It is, so example, this is 7. For that, definitely let's say you tell me a longest path from Hyderabad to Kolkata which is going through Vizag. So do you think for Hyderabad to Vizag also should I go in longest path? No. What I do is, to form longest path from Hyderabad to Kolkata, in that I am visiting Vizag. Okay, this is what my path. Vizag, then Vizag to Kolkata. But Hyderabad to Vizag to visit, should I take longest path? Not required. I take shortest path, you see. Hyderabad to Vizag, you have 2 paths, 5 plus 7, 5. But I want Hyderabad to Kolkata longest. For that, Hyderabad to Vizag, I am visiting with shortest. Still, I will have longest, how you see. Once I come to Vizag, then Vizag to Kolkata, I will go like this. Vizag to Patna, Patna to Hyderabad. I make a loop like this. So here I take loop, longest loop, so that will become longest path. Then overall will become longest. Example, you see, infinite. How? 7, 5, 5, 7, 5, 5, 7, 5, 5. I keep on visiting. So that I'll make it longest, as longest as possible. Then overall will become longest. Example, if it is infinite. Infinite plus 5 is again infinite, correct? So that's why here you don't require another infinite. That is what I wanted to say. So longest path problem doesn't have optimal substructure. To go from Hyderabad to Kolkata in longest way, if you visit some other city, that is conditional. If you visit Vizag in between, then going to Hyderabad to Vizag, which is a sub problem, that need not be done in dash way, longest way. That you can do in shortest way also. So one shortest, one part is shortest, but second path I do longest. Then overall will become longest. Example is this one, right? So I took only 5 rupees cost path. Here I took infinite path. Then overall it become infinite. Understand? Second one, here you take infinite. Then after that you take shortest path. That's why this is one example which is longest path problem which doesn't have optimal substructure, right? There are. Sir, tell me one easy problem which has optimal substructure so that we can understand it clearly. Very simple. One is shortest path problem. You already understand. Correct. Second one, this one you see. In your life, you want to earn as much money as possible. There are two stages. Example, let's say currently your age is 25. So you are going to have 40 years after some time, right? Then eventually your age becomes 80 and after that you die. Then my question is, if you want to earn as much money as possible, that is what your goal. Okay, you are optimizing what? You are not optimizing happiness, you are optimizing the money you have. So finally you want to earn, I mean, huge money. That money is nothing but the best money you can earn. Then there are two things, 25 age to 40 age. Then here let's say you can earn only 1 lakh. That is the best way. And 40 to 80, let's say you are going to earn 5 lakhs. This is best. You can't do better than that. Okay, just giving the possibility. Then overall best will be 1 lakh plus 5 lakhs. In the place of 1 lakh, example, if you earn only 50,000, but still you are capable of earning 1 lakh, that is your best. Then if I take only 50,000 here if I take 5 lakhs, then 5 lakhs plus 50,000 cannot be overall optimal, correct? So here what is optimal? You are optimizing here money, correct? So you want to optimize your money from your 25 years age to 80 years on that. So there is a, let's say, middle point called 40. Then 25 age to 40 also we have to earn in dash way, best way. That's why we have to earn 1 lakh. Then here 40 years to 80 years you have to earn best way. Then 5 lakhs. Then only overall will become best. Rather than that, if you waste your time here 25 to 40 and if you don't earn anything, let's say 0 rupees, then overall you can't make highest. Sir, I do one thing. 25 to 40 I earn 0 rupees, but here I earn 10 lakhs. That is better than 5 plus 1 6 lakhs, no? Yes, you are right. But if you can earn here 10 lakhs, keep the 10 lakhs as it is, then change it to 1 lakh. Here if you earn 1 lakh, overall will become what? 11 lakhs, correct? That's why what irrespective of this value, here this should be done in best way. Then only overall will become best way, correct? That's why this problem, earning money in your life has optimal substructure like this one. So finally, if you want to come in a best way, example, finally I will tell you, let me summarize. So what is your goal? You want to start it here in first stage somewhere, either line number 1 or line number 2, but you want to finally come to this one, like you want to come here with some path, correct? That path is, let's say, something this path name is P14, which is just coming through line stage number 4, line number 1. So one path is going to, because there are lot of paths, there is one path which is coming through P24. My question is, this P14 is dash, then only you want it, tell me. So this P14 I will select only if it is minimum cost path, correct? So minimum cost path definition is what? We are denoting it by F14. So what is the minimum cost path among all the paths which are going through P24, A24, they are, what is the best path? We are denoting it by F24. Of course, we don't know the value, but we are just denoting. So we are going to find out the value. Let's say somehow you got it. That means you realize that from in all the paths which are going through stage number A14 is, stage number S14 is 100 rupees. There is no better way. Remember, what is 100 rupees? Among all the paths which are touching S14, 100 rupees. All the paths which are touching S24 stage, among them best path is 200 rupees. Then you tell me overall best is what? 200 plus 90 is this finishing, and here 100 plus this 70, 170. Among them best we have to pick. We know the logic for that, correct? So 170 or 290, which one is minimum? That is the answer, correct? So similarly here also what I am going to do is, final answer is very easy. First of all, calculate the best path which is coming through stage 14. The notation is F14. Find out the best path which is coming through stage number 24, F24. Then for F14 add X1. For F24 add X2. Then identify min. That's it. That will be the final answer. But how to compute F14, how to compute F24 is the question I am going to answer.